So for those of you who were here yesterday, welcome back. For those of you who are new to the Git one, welcome, good to have you. We're gonna do the same thing that we did yesterday using HackMD, which is a little, it is sort of like a Google Doc, but it is in Markdown. It's a lightweight little language for making nicely formatted text, nice for note taking and stuff like that. So in this, you will see, if you go to that link, you'll see some information on a link to the lesson webpage for the lesson we'll be teaching today. Today's Zoom link in case you get logged off and need to find that quickly. And then some information on setup, which should have been sent to you in the pre-workshop email. If you haven't gotten that set up yet, then you can go ahead and follow the instructions that we linked there. And feel free to let us know if something went wrong with trying to get that Git set up on your computer. So yeah, we'll need, basically you'll just need to be able to use let's see, you'll be able to, you should have to have Git accessible to you, a terminal, and be able to use the bash shell. So if you can do all of those things, we're good. We'll give a few more minutes if everyone wants to check in on that. I'll put the HackMD link in here again. Give you a few more minutes if everyone wants to just check on that, make sure everything is working correctly. And then we'll touch back. All right, so I'm going to do a little bit more intro. So for that HackMD, if you want to check that out quickly, one other thing I'll add is down at the bottom, we have a questions and comments section. So the Zoom chat is a good way to get a hold of one of the instructors. So if I'm teaching, you can go ahead and send Ryan a direct message on here if you run into any problems, like something just isn't working on your computer. But if you have more of a conceptual question, just like, oh, I'm curious about this, or I'd like to know more about this, you can go ahead and put that in the HackMD. It's just a little easier to find, a little easier for us to respond, and so that everyone can have access to those questions and answers past the duration of the workshop. So the way we'll have that formatted is down at the bottom there, you can type out a question in the form of a bullet point, and then one of the instructors will give you an answer as a sub bullet to that. So we'll have a nicely formatted list of questions and answers at the end. One other thing I want to do before we get started today is just acknowledge that we do abide by a code of conduct with these workshops. So we're dedicated to providing a welcoming and supportive environment for all people, regardless of background or identity. By participating in this community, you accept to abide by this code of conduct. Any form of behavior to exclude, intimidate, or cause discomfort to other people is a violation of this code of conduct. In order to foster a positive and professional learning environment, we encourage the following kinds of behaviors on platforms and events. So use welcoming and inclusive language, be respectful of different viewpoints and experiences, gracefully accept constructive criticism, focus on what's best for the community, and show courtesy and respect towards other community members. So, you know, we're not going to have a ton of group work today, so that's, you know, not necessarily going to be the case, but just want to acknowledge that. Just be kind and thoughtful towards each other. So we are going to talk Git today. So the assumption is that you have at least some familiarity with working from the command line in the bash shell, and we'll be interacting with Git primarily in that way today. So as I noted, we have the link to that lesson, the software carpentry Git lesson, is linked in that HackMD. So we'd recommend that you have a terminal window open on your computer, the screen sharing when we're sharing our own screens with you. And then if you have enough space, then it can also be useful to have the lesson open just so you can follow along there as well. All right, with that, we will actually dive into the lesson today. So first, I just want to walk through a little bit of the, let's see. We're going to walk through the lesson because this first chunk of the lesson is primarily graphical. So, oh gosh, that's a link. So we're going to be talking about using Git for automated version control. Now, it can be maybe sometimes unclear, why should I use Git? What's the point of all of this? It sounds like a big hassle, but we want to walk through why it can be worthwhile to use something like Git. So I don't know about any of you, but I relate far too strongly to this, this comic here. It's the idea of having you know, tracking changes to documents by changing the name from final to final2 to final, no, actually this is the final one, to oh no, that wasn't actually the final one. It can get very, very complicated and messy very quickly. Even as someone who uses version control as much as I can, I still find myself doing this, and every time I bash my head against the wall for continuing to do it. So there are various ways to handle this issue of tracking the changes that have been made to a document. Microsoft Word has track changes, which people are likely familiar with. Google Docs has a nice version history, which can track versions of documents. And then LibreOffice, if that's what you use, has a recording and displaying changes option. But basically how all of these different approaches work is it's quite similar. You have a document, as we see here, and instead of keeping track of every single version of the document, it keeps track of the actual changes that are made. So it's something like a recipe where you start with a base version and it keeps track of what changes have been made to it to get to the final version. And by reversing steps of that recipe, you can go back to previous versions. So it's really useful to think about these changes being actually separate from the document itself. So you can then sort of think about these rewinding steps as reversing these changes that exist sort of separately from this document that they're acting on. This also makes it easier to handle situations where two users make independent sets of changes on the same document. So you could have multiple people working at the same time, and as long as those changes, as we see here, are being made in different places, you can incorporate those two changes back into the same base document. Now, if you are changing the same lines as someone else, we run into what's called a conflict, which is something we'll talk about later today. But in general, this flexibility allows us to work collaboratively on the same document with other people and combine our changes more seamlessly than we will be able to otherwise. So a version control system is a tool that's going to keep track of these changes for us, which essentially track the changes between these different versions. So each record of these changes that has been made, so each time you say, okay, this is a set of changes I want to document, that's what's called a commit. And version control systems typically keep some information about those commits, like when they were made, who made them, things like that. Then the complete sort of history of changes that have been made for a document or even a whole series of documents in a project are what we would call a repository. So these repositories sort of say, okay, across everything contained in one folder, what are all the changes that are being made? And these can be made across multiple documents, multiple people making those changes, but it keeps track of, you know, how can I roll back each of these steps to get back to different stages? So these repositories then can be kept in sync across different computers. So you might be wondering, okay, how am I going to collaborate with someone on this? Well, a repository that's kept track of by a version control system can live on your computer, but it can also be synced to something like GitHub, GitLab, Bitbucket. Basically, these pieces of software have been around for a long time. This has been a problem basically ever since, you know, how to keep track of changes in collaborative documents has been a problem for as long as people have collaboratively worked on things on computers. One thing that I think was useful for me when learning Git was to acknowledge that it's just a really hard problem to solve. Like how to keep track of changes that multiple people are making and doing all of this is really difficult. And things like Git are the best we've got at the moment. So if you ever get frustrated and you're like, this seems like a lot of work, it sometimes can be. And it can sometimes feel frustrating and like, oh, is this even worth it? But it's a very difficult problem to solve. If we had any better way to fix this issue of multiple people collaborating on things and tracking changes, someone would make a lot of money on that. So next thing we'll do is we will actually move on to getting our Git set up on our computer. So if you have Git successfully installed, which you should at this point, you can open up a terminal window. So I have this bash terminal window open, and we'll be doing everything from our desktop. So you can type cd desktop. Oh, where am I? I am already on my desktop. So if you do cd tilde, that will make sure that you're in your home directory, your my user directory. And we can do cd desktop to make sure that we're all working in the same place. So when we get Git set up on our computer, we need to configure some things just to make sure that when we work later on, things work nice and smoothly. So a couple things we want to change. We need to make sure that Git knows our name and our email address so that any changes that we make to Git any commits that we make to a file or repository will get tagged with our name and email address, so that if we're collaborating with someone later on down the line and they want to know who made a particular change, they know who did it. We also might want to change what our preferred text editor is, because Git will at times need us to use a text editor to change things. And then we want to make sure that Git knows that we want these changes to be global. So you can set these sort of things specifically. Like if you want to use a different email for a particular repository, you can set it for that one. But for now, we want to set these things globally, just so whenever we use Git on our computer, it knows who we are and some of those configuration things. So on the command line, anything we do with Git is going to start off with Git. So Git will be the first command we give. And the way it typically goes is Git verb option, where Git tells us, all right, or tells the command line, yes, we want to do something with Git. The verb is some command that we actually want to do. And then the options are additional information to let verb know what we're doing. So if we want to set up our Git username and email, we can start off by typing Git, and then what the verb will be, the thing we want to do is config, which stands for configuration. And then we will pass it a flag, which is something we talked about yesterday, global, which will tell Git that we want to set these things globally. We want these to be applied to all repositories whenever we use Git on our computer. And we'll do user.name, and I will put in my name. And if I run that, it should configure so that now Git knows that my name, whenever I make commits, is this. So you can try this, put in your own name, obviously, probably not very useful to put in my name for you. We can do another one, which is git config -- global again, and we'll do user.email. And similar thing here, you can put in your email. Mine is already set and I don't want to mess with that, so I will not set it, but your email at place.com, right? So you can put in your email, hit enter or return to run this line. And now, now this username and email will be associated with any Git activity on your computer, which will be nice so that when we start using GitHub later on and someone else sees what's going on there, it'll work. One thing to note, we're going to be using GitHub later on. So if you have a GitHub account already, you should use the same email that's associated with your GitHub account for this. And if you don't have a GitHub account yet, then know that you will be using this same email to set up your GitHub account later on. So just make sure that you're going to be consistent about which email is used there. Also note, you can change your email here by rerunning this with a different email, and you can change your GitHub email as well. That takes a little bit more work, but that's totally doable. All right. So, all right. Another thing we have to do is that we have to set a couple other little things that will make things work nicely. We'll continue on from here. On the lesson, I'm gonna actually skip this part. On the lesson, there's a little bit about line endings. So occasionally when you're tracking the changes between documents, different computers can like encode the end of a line slightly differently. So you can go ahead and check that out just to make sure things work nicely there. But the next thing we'll have to configure is our text editor. So Git will occasionally need you to edit files, like if there's a conflict between two changes that are being made, it will ask you to edit that file to fix that conflict. So we can let it know what our favorite text editor is. So it's actually a little bit easier to just go to that place on the page. Chat, here we go. I'll put this in the chat. If you follow that and go down, there's a text editor configuration section. But basically the way this command will look will be git config -- global core.editor. Now, I would recommend using the nano editor. If you're unfamiliar with any of the other options, it's probably the easiest one to use. And you would do that by typing nano-w in quotes. So I would recommend doing this if you're unfamiliar with any of the other text editors. but there are a bunch of different options there that you can use to set your preferred editor. All right, continuing along. Another thing we'll want to do is configure the name of the branch that gets created when we create a new repository. So it used to be the default that the branches that you create, the default branch, we'll talk about what branches are later. But essentially, they're just different sort of versions of a repository that can be worked on and merged together and split off from each other. But by default, Git will create a branch called master, which the software community generally has moved on from the term master since it has connotations with practice of human slavery and generally something we want to avoid. So most places have transitioned towards using the word main to refer to that branch. So you can actually set that by running git config -- global and then init for initialize dot default capital B branch and then a space and then main. And then Git will know that whenever you initialize a repository, we want to use main. The other thing is, like most like hosting services like GitHub and GitLab default to main as well. So it'll also make your Git work more nicely with those. So one nice thing is we can actually check our Git configuration by running git config -- list. And that will tell us all of the Git configurations that we've made beyond the default sort of Git settings. Now mine is much longer because I have all sorts of other stuff in here, but you can see things like my username, my user email. We've got that init.default branch is set as well. So you can always check things here. So if you ever need help with any of this Git configuration stuff, any Git command, so like git and then config. So config is a command. If I just run it bare like that, it'll say, oh, here are all the options you can pass. It gives me some information on it. Another way to get that information is to type git config -h for help, or you can actually type out -- help. And this will give me even a little bit more. So I can scroll through this much bigger manual. This manual has a lot of information on different things you can do for the git config command. To exit this little viewer, you can press Q, which will bring you back to your regular command line. Then more broadly, we can actually get help by just typing out git. So help is the actual command, and that will get us a broader set of Git commands that we might want to use. So things like starting a working area, working on current changes, examining changes, all sorts of stuff like this. So at this point, I'm going to take a quick pause. Any questions as of yet? This is a good stopping point if anyone has any issues or any, if you have any questions you want to ask right now, go for it. You can put them in the chat, or otherwise you can put them in the HackMD. All right, so we will move right along then. So now we've got Git kind of set up. We've got some of these basic configuration steps done. We can now move on to actually creating a repository. So once Git is configured like this, we can actually use it. So the little story example that's used for the Git lesson here is we're going to imagine that Wolfman and Dracula are investigating if it's possible to send a planetary lander to Mars. So Wolfman and Dracula are collaborating on this project. So first, let's make sure we're on our desktop, pwd, print working directory from our desktop. So we should all be in our user and then desktop location. So the next thing we'll do is we'll make a directory here using the mkdir command. So we'll do mkdir planets. So let's type out mkdir planets, which should make a directory called planets, which we can then cd planets to move into. So we run that, pwd to check and make sure that's where we are. Wonderful. So now the next thing we have to do is we have to tell Git to make this planets directory into a repository, which is a place where Git can store those versions of our files. So this is an important thing to think about that I think can get kind of tricky, is we get a lot of terms like repository and project and a directory. It's worth thinking about that those are all just a folder. Like all of these things are just a single folder that contains a bunch of stuff. It can contain lots of other folders, it can contain files, programs, software, whatever, but it's just a folder with some extra features. So our planets is a directory or folder on our computer, and then we're going to make it into a Git repository as well, which is just a folder that Git is going to keep track of. It's going to keep track of everything in it. So to initialize a repository, we type out git space init. If we run that, it'll say, and initialized an empty Git repository in users mj desktop planets.git. So you can see that because .git ends with a slash, that means it's a repository. So what happens is Git will make a folder inside planets called .git where it keeps track of all of this stuff. You generally don't need to go in there, but that you should know that that's what's in there. So Git init creates a repository that will include all of our subdirectories and files. You don't need to make sure to add anything. Anything that we add in planets after this, Git is going to keep track of. So you can think about it, once you initialize this, Git is watching everything that happens inside planets. Anything you add, anything you remove, Git is watching it. So if we type out ls to see what's in here, we don't see anything come up, although we were just told that Git started something in here. So if you recall, the ls doesn't show us hidden files and directories, which start with a dot. So it will not show us .git. So to show everything, we can do ls-a, which means show all. We run that, now we see we have this .git directory. So Git uses this special little hidden subdirectory to hold all the information. One thing to note, you should not remove .git. If you remove the .git directory, Git will lose track of everything that it's keeping track of. That's like where Git is storing all the information, all the history of this repository. So be careful, just don't mess with that .git. So depending on the settings, if you set that init default branch, it should be called main, but we can check and make sure that we're in the main branch by running Git Checkout main. Here, Git Checkout, sorry, -b main. Okay, so that should make sure that we're on this branch called main. Git Checkout, and then that -b stands for branch, and just make sure that we're in the main branch. now we can check that everything is set up nicely in here by running Git Status. So Git Status is something I run quite frequently just to check, see where things are at with my Git repository. So it will tell me some information. We'll say that I'm on branch main. I'm on the initial commit, and there's nothing to commit. Basically, there's nothing else in the repository. So there's nothing for Git to even keep track of yet. Note that if you're using a different version of Git, you can occasionally get slightly different wording than we might see here. So, all right. Now we are going to have you do a brief little exercise, which is going to be reading through. I will link to it here. One sec. So there's an exercise on this lesson that we're going to have you go through. So places to create Git repositories. So one thing to note, there's some code here. You should not run this. Just read through it and then answer this question out at the end. If this is this git init command inside the moons subdirectory required for tracking files stored in the moons subdirectory. So read through this, try to answer that question honestly to yourself, and then you can check the solution with that drop down arrow and see if you were correct on this. So we'll give you 2 minutes to run through that. Oh, I forgot, but if you could use the little Zoom reactions and put up a green check for yes if you've completed this, and you can put up a red check for no if you've run into any problems. And as always, feel free to put any questions into the HackMD, or you can ask in the chat. All right, I think we're about good now. So we've had an opportunity to run through this. So the answer to this exercise is no. We don't need to make this moons subdirectory into a. Oh, okay. Just got a message from Ryan that we've got still a little bit of some time with getting the setup right. So yeah, I think we're doing pretty well on time actually. So I think we'll do, let's say if you've got all of the setup done and you're good to go on all of the setup stuff, feel free to take a 5-minute break here. If you're having any issues with getting the setup, we can, we'll take a 5-minute chunk here and work through any issues people are having with doing the Git setup stuff. All right, so yeah, 5 minutes, let's say at 41 after the hour, we will convene and start back on the rest of the lesson. All right, so we've reached the end of our little 5-minute time. Hopefully everyone has gotten some of those any setup issues sorted out at this point. If you still run into any more issues, again, feel free to message someone on Zoom. So we'll return just briefly to this little challenge we just went through. So essentially, in this little example, Dracula sort of made a mistake here by creating this moons subdirectory under within the planets directory, which is fine, right? You will likely create subdirectories within a repository at some point. But then Dracula went into that moon subdirectory and ran git init, which turns that into a repository as well. Now, this can cause some pretty big problems down the line. So what happens is if you have a Git repository nested inside another repository, you can the parent one, the outer directory, Git will try to track everything that's being changed inside that other one. So it's going to try to track the changes that inside that .git folder of that moon subdirectory, and that can run into just all sorts of weird problems. So I know I said generally we don't want to mess with the .git folders, but I'll show you what would happen. So let's say I actually ran these commands like Dracula did. I make mkdir moons. Now I have this moons. I can go inside it. I'm inside moons now. If I run git init, and then I run ls-a, I can see now inside moons, I have this .git repository. And like I said, that's going to cause us some problems. Luckily for us, .git is where all of the Git information is stored. So if you don't have that .git folder, that .git repository, then Git doesn't track anything. So if you accidentally make this mistake at some point, you can go in, and if you just ran git init accidentally and you didn't want to, you can remove this .git repository by running rm-rf. Actually, sorry, we'll go up one level. So now we're in planets, and I can rm-rf moons/.git. So be careful with this. You don't want to remove a .git folder that has stuff in it that like you've been tracking changes for, or you'll lose all those changes. Now, this is just to reverse this little mistake I made where, oh, I initialized a repository inside another one. Didn't mean to do that. I can run this. And now if I go into moons and check, there's no .git in there. So now we don't have these nested repositories. So one thing I've seen in teaching Git to folks is that people will sort of go gung-ho and they want to then turn everything into a repository. And what can often happen then is, you know, someone maybe they make a repository called like dissertation. And they're like, okay, I'm going to keep track of all my dissertation stuff in here. And then maybe at some point they make a chapter 1 folder inside that. And then they go, okay, well, I want a chapter 1 repository. And they turn that into a repository and they get this nested thing. It's generally worth thinking of repositories as just these separate, discrete directories that live on your computer. Now, what sort of level of granularity you choose for what you want to be one repository, that's a bit more of a personal choice, right? I would prefer maybe to do each chapter of my dissertation as a repository, because those seem like nice discrete units that will contain everything I want. Keeping them separate makes them a little more manageable. Whereas if I was to do my whole dissertation as a single repository, that might be just too much stuff to really effectively keep track of. So keys don't nest repositories, but you can, it's up to you sort of what you want each repository, what scale you want that to be. All right, so with that, we finished up our creating a repository section of the lesson. Now I'm going to hand it over to Ryan to take it away with actually tracking changes.
All right, thanks, Michael. All right, so up until this point, Michael has showed us sort of how to configure Git in the command line, how to initialize a repository, but we really haven't done anything with it. We haven't versioned any like text files or programs or anything like that. We have a clean slate in this planets directory to start making some changes. And so in this next episode of the workshop, we will be actually creating files and tracking the changes that we make in those files. And so this is the powerful part of Git. This is why we teach people this. This is something that I find myself using more and more with each passing year. It's so much easier when you're working on code-heavy projects to use this versioning and some of the hosted Git, like GitLab or GitHub or any of the other Bitbucket and any other alternatives, or like hosted Git. Super powerful. People kind of harp on backing up your data. And so like if you follow the whole arc of this Git lesson, this will help you back up your code. And it'll make it to a point where at the end of today, you'll be able to see how all the pieces are connected. And I find it's great. I just got a new laptop and I was able to get all of my projects from GitHub onto the new laptop without having to install anything except Git and set up the credentials. Super, super convenient. All right, so first off, we'll get into the actual demo part. I'll get off my soapbox for a second and we'll go to our desktop. Spelled that wrong. Desktop and then planets. Now I'm in the planets directory. You can see that there's still nothing in it. If I do the ls-a, I have my .git file in here, folder in here rather, that's keeping track of all the changes that I make to this directory. So let's create a file. Let's use nano to do so. So I can do that by typing nano mars.txt and sticking with our supernatural horror expedition to Mars theme of today. We're going to start taking notes on the habitability of Mars by Dracula, Wolfman, etc. So I have nano. If you weren't here yesterday, this is what nano looks like. The commands, the short commands for getting in and out are down at the bottom. The up symbol, the caret symbol next to the letters is the control key. So if I type in cold and dry, this is about Mars, but everything is my favorite color. That's not true. My favorite color is not red, but for the purpose of the lesson, it is. So I will write this out by hitting Control O. It'll say, would you file name to write, mars.txt. hit enter, and then I can hit Control and X to exit. So now if I ls in this directory, you can see that I now have this mars.txt file. So that's created. We didn't cover this explicitly yesterday in the Unix shell lesson, but this is the cat command, which is short for concatenate. This will print the context of the contents of a text file into the terminal. This is not something you would necessarily want to do with very large files. For the purposes of this, will work just fine. So if I do this, it shows me the inside contents, thus confirming that everything I wrote in nano is actually contained inside the file mars.txt. All right. So now this is getting back to what Michael was saying. So if we run Git Status, this is going to tell you sort of where are you at with your version, your Git version control. What changes have been made? So I'll hit enter. So you can see that I'm on the branch main. I have not made any commits. We'll get into what commits are in just a few minutes. But it is notifying me that I have these untracked files, and it's suggesting please use git add and then whatever the name of the file is to include in what will be committed to the Git history. Nothing added to the commit, but untracked files are present. So again, it's warning us like twice that we have something that Git is not currently keeping track of. And so now I'm going to use the command that Git suggested to me. I'm going to use git add, and then I'm going to type mars.txt. Okay, and so nothing happened. So I did git status. It told me everything that Git was doing. If I do git add, it doesn't explicitly tell me that anything happened. So if I type git status again, we can see now that this has changed, right? So before we have this in red, this is saying that this is an untracked file. And now we've told it to add the file to the tracking. And again, we run git status. It's saying we are on the main branch. We have no commits yet. And then the changes to be committed are this new file, mars.txt. So you can see all of the suggestions of adding things are now gone from the git status. So the next step is to commit. And so what the commit is it is creating that sort of part in the history, but you're also supplying a message to Git. And now I've worked with other people who write really cryptic commit messages. Don't be the cryptic commit person. Nobody wants to read something that looks like prose. Just tell Git exactly what it is that you've changed in a succinct way. So we're going to type git commit -m. We're going to say start notes on Mars as a base. And it's important that the -m flag, you follow everything with quotes afterwards. This is actually going to explicitly go into the history. And later on, you'll see, as you start to use like hosted Git, that these messages will pop up like on GitHub in like the hosted repository on the web. So if you're making changes, keeping your commits succinct and informative is really, really important. Like found an error in line 28 of this data preprocessing program. That is a perfectly fine commit message. You commit that. The people you're working with will know exactly what you did. And it'll label it that you made the change, that exactly you're giving an informative message of what you actually changed. And then in some of the advanced features, some people can review what you have done. And that will be something that we cover for those of you staying on with FOSS. We'll get into like extending this Git into a collaborative platform. Okay, so I hit enter for my Git commit message. And so this is giving me a message saying that on main, we committed, and this right here is a hash number. So these hash numbers, these are generated by Git, and this is telling you every time that there's a change, it's going to give a new hash number to it. So you can go backwards in time, right? It's a little more complex than using like track changes or the history in Google Docs. But when you're working with a lot of programs, potentially a lot of text files, it could be pretty good. And when I was in your shoes, I learned Git through carpentries as well. I thought I will never ever need to use this hash history thing until I had to. And it was like I made a bunch of changes really, really quickly, committed them all, and then nothing worked. So I had to go backwards like a week in my commits. So whenever we run this commit, Git is going to take everything that we told it to save with git add and store a copy inside that hidden Git directory. The permanent copy is the commit, or you could think of it as a revision. And then you have the identifying hash number. If you run git commit without the -m option, this will pop up whatever you set up your core.editor text editor to be. So if you changed it to Nano along with Michael, it will open up Nano, and then you can do the same thing, write out your message, save it, exit, and then Git will accept that, and it will go into the Git history. So now, if we go back and we run Git status after we did our commit message, you can see that we're still on the main branch. We have nothing to commit. The working tree is clean. So when we say the working tree is clean, that means there are no new changes in any of the files, no new folders, nothing. This is how we know we're up to date, right? Like we don't have any work that is untracked inside of the folder. And if we want to look at our entire project's history, we can use the Git Log command. And so this will give you a full, so you see right here, this hash number at the beginning. So this is the full commit hash. This is automatically generated by Git. This is telling us that the commit was made to the main branch by myself with my associated email address, the local time, it's Arizona time, and then it gives me the commit message right here. Start notes on Mars as a base. So if we go through and we want to say, okay, well, where exactly are my changes? If we run ls, you can see that we only have mars.txt. And then this is because, like I said a little bit earlier, this is all, the history is all stored inside that hidden Git directory, which we can find by ls.a. So and actually, if we want to do this, you can see that it's a directory. So let's say we want to add some more information to our file. So we're building out our notes as Dracula. We're trying to get all of our supernatural horror characters onto the Martian surface. So if we go back to Nano and we open the mars.txt file, and we want to go if you were wondering what I just did that magically took the cursor to the end, I have a full keyboard and I pushed the end key. So a lot of the like home, page up, page down, end keys on the keyboard inside these command line text editors, they'll sort of zip you around from the beginning or end of the line. Which is what they're originally designed for. And so if I want to add more to this, and say the 2 moons may be a problem for Wolfman. Presumably Wolfman will constantly be Wolfman and never turn back into a human being. And for whatever reason, Dracula finds this problematic. So we can write this out again. So I did Control O and then Control X to exit. Now, if we check this again with the cat command, mars.txt, we can see right here, we have this next line. And so now if I run Git Status again, you can see that now it's saying that I have modified the mars.txt file. And if I scroll up in my Git history, or my command line history, rather, you can see the first message was untracked files. And now that we've made changes, it's telling us that we have modified a file that is actually being tracked by Git. And now, if you want to, you can do the git add, but let's try a different command right now. Right? So what we want to, this is a good sanity check. So if you do git diff, that will tell us the differences between the changes that have been made. So this is saying from the old mars.txt to the new mars.txt, we've added things. So this is less lines, so hence the negative signs. And this has more contents, so hence the plus, plus, plus. And you can see down here, what I added to that file is now highlighted in green on my terminal. This might be different on yours. I have syntax highlighting set up by default in my terminal so that I get these visual cues, red and green and all of those things. So this is kind of, the output's a little bit cryptic. Similar to the Unix command diff, which compares old and new versions of a file. So that is a command line program that you can run. And the second line of this is telling us explicitly that it is comparing a couple different hashes, right? And so now if I go and I do git add, and I do a dot, it will add all of the new changes in this folder, in this repository to Git. So if you remember, if you were here yesterday for the command line, we talked about orthogonality of the file system. So the dot, just the single period, is shorthand for your current working directory. So if I do git add the dot, and then I go to git status, you can see that it did the same thing. It added the mars.txt file. And so now this is added without actually having to explicitly type the file. So using the git add with the period is really great if, say, you created 3 or 4 files and you don't want to go through and explicitly add all of them individually. This will add all of those to your Git repository. And now we can write a commit message again. So do git commit -m. Remember, if you don't do the -m, it'll open your text editor, and then you can do the exact same thing, write a comment, and that will get stored in Git history. So if I do git commit -m, double quote, add concerns about effects of Mars's moons on Wolfman. Okay. So this gives us a new hash right here next to main inside the branch. And this is telling us that one file changed and we had insertions. So this means we added something. If I was to delete a bunch of lines in that file, it would say deletions, and it would have a negative sign. And if you do insertions and deletions in multiple files, you'll get different messages in the commit itself. So if you run the commit message without doing add first, it will show an error. So we didn't commit any of the changes. So if you look at page and examples right here, if you run the commit before adding anything, it will just say no changes added to commit. Use git add or git commit -a. So you need to run add or use a flag to sort of skip ahead and not actually explicitly write out git add. So Git is always going to insist that we add these files we want to commit before actually committing to anything. The git commit -a flag stands for all. So you want to commit all in your repository. You can also explicitly write it out by typing git commit --all, and you can put like a -m flag and then write your message. Commits. So it says nothing to commit, working tree clean. But if I did have changes, this would automatically add everything and then put another commit as the message, which I broke my rule of writing an uninformative commit message. So there's a nice diagram. If this is kind of making, if this is kind of getting to be a little bit confusing, there's a nice diagram right here. So this is straight from that page. I just posted a link directly to the image, the vector image of that. So the git add is taking a document that is, let me just open this up and walk everybody through this. This is conceptually important. Okay, so I'll just zoom in on this a little bit. So this is taking, so you can think of this as our mars.txt file, right? And so this is taking this document, which is outside of .git, which is the sort of representation of Git tracking all of the changes. And this is taking it from outside of the land of Git and moving it into Git. And when you run add, it puts it into a staging area. So this is now Git is aware that it should be keeping track of this, but it hasn't explicitly added it, or it hasn't explicitly committed it, rather, to use the proper verbiage, to the repository itself. So we have this document, we've added it, it's now in the staging area. We can decide, do we really want to add this? Do we want to remove it? Do we want to go backwards? And if we want to move ahead, we can move ahead with git commit. And my point of sort of rambling through the -all flag, git commit, is the -a or --all bundles this all together so that it takes you straight from here all the way to here. Hopefully that diagram helps. The new diagram in the lesson, and I think it's pretty informative about what Git actually is doing. All right, so if we want to add another line to the file, mars.txt. So wrote down our concerns about Wolfman, but the mummy will appreciate a lack of humidity. And then if I hit it, O to write, and then Control X to exit Vim. Just screen. So now I can run git diff again. And this is going to tell me again that between my last commit, so now you can see right here, so there's this, I ran git diff and saying the diff -- git. Now in this case, it's taking our mars.txt file, since we've already went through the process of adding and committing. It's starting from with the A version of Mars as the 2-line version of the text file. So our old version, or oldest version of this file was just this line. The newer version is these 2 lines, and the newest version that we would like to commit adds this line. And that's what the git diff is telling us right here. And so now if I run git add mars.txt, okay, again, nothing happens when you do the add. Do git diff. Git diff doesn't give us any output. So as far as anybody, as Git can tell, there's no difference between what it's been asked to save permanently and what's in the current working directory. So since we've now crossed, if you remember the diagram that I just showed, since we've now crossed with the add into, for lack of a better phrase, the land of Git, it's not seeing it when we run the diff, right? So what we need to do is, since now we have told Git to add the file, we can use a flag for git diff called staged. So anything that is in add that has not been committed is staged. So if we want to look at the differences between staged files and what we've already saved in the repository folder, this will give us the exact same output that we had before we added the changes from that file. All right. And so now we can make another commit message, and we're going to say git commit -m. I'm going to say discuss concerns about Mars's climate for money. Okay. And so again, it's going to give us that version, that hash of the next version of our repository in the history. And it's going to tell us that one file was changed. And again, we've only inserted into the file. So we added another line. There's one insertion. And if we run git status again, it's going to say on branch main, nothing to commit, working tree clean. And now we could take a look at our log, at the history of Git, and then we'll have a lot more to see here now. So you can see that when I run git log, it prints the most recent commit at the top and the oldest at the bottom. So as you go through and add things to the repository, the newest stuff will appear first, and then the original commits to the repository will appear last. You can see that each of these commits, after the word commit, there's a different hash. So those are explicitly referencing the save points within the repository. So there's a few other tricks inside of git diff, such as color words, and those are all referenced inside of the Carpentries documentation. There's also git pager. That happens when it's too long on the screen. And the git pager is similar to Vim. So you would push the colon and then Q to quit that. That's only going to happen if the log is super long and won't fit entirely onto your screen. So if we want to limit the log size, so say we only want to look at the last commit, the latest commit. So say git log and then -1. It will give us the most recent. If I change that to 2, it's going to include the first 2 commits. So this is a way of avoiding having to scroll through the long pages as your projects start to get bigger and bigger and you make commits. It seems like that wouldn't, based on this example, that wouldn't necessarily happen, but sometimes when you're working on versioning programs or scripts or anything, sometimes you can make multiple commits in the same day, and you kind of want to limit it to just maybe the 4 commits that you made on that day, and you're sort of looking at your log at the end of the day. You can also look at the reduced quantity of information using git log and then --1 line. And that will reduce the commit history into the shortened hashes with each commit message next to it. So you can see this is the first hash that we got, and then the first commit message we made, second hash, second commit message, and then the latest one. You can also add the option graph, which adds these little stars to the beginning. So there's another interesting thing about this, and this is something that I constantly forget with Git. So if I want to make a directory, I'm going to call it spaceships. We're going to start looking at spaceships for our bizarre mission to Mars. So I'm going to make this spaceships directory, and I'm going to type git status. So I've created a directory, and for all intents and purposes, that I've created something new within the repository. There's nothing to commit. Okay, that's really weird, right? We created a thing, so why isn't Git keeping track of it? So do git add spaceships, and then let git status. Again, nothing happens. Doesn't appear on the list of untracked files, even if we explicitly add it via git add to our repository. This is the reason why you see these git keep files and otherwise empty directories. Unlike git ignore, they're not special, and their sole purpose is to populate a directory so that Git adds it to the repository. So if you create a directory in your Git repository and you populate it with files, you can add in them all at once. So if I want to add a few files to this, let's say we're going to use the touch command. So this is going to create empty 0-bit files. I'm going to create them inside the spaceships directory. We're going to call this one Apollo 11, though I don't understand the physics of Apollo 11 reaching Mars. Neither here nor there. And Sputnik 1, I don't understand how you get a werewolf on it. But we're going to add these spaceships, possibly our worst options for spaceships for this mission to Mars. And so we're going to do that by a touch, right? So this is the touch command. It's going to create 0-bit empty files. I'm saying this is the folder, / and then this is the file. This is the folder, and then / and the file. These are the files that I'm going to create. Touch. Okay, and so now if I go to git status, see now it's recognizing that I have untracked files inside of that spaceships folder. So in order to add a folder, you either need to add a .git keep file, which is a bit beyond the scope of today, or start creating files in the folder, and then you'll be able to track the changes. And so you can commit that. after we add it, so we're going to say git add, and then we can do this, the folder itself. We add spaceships. And so this, when you use git add with a folder, it will automatically include all of the files inside of that folder. So do git add spaceships. Again, like everything else, nothing happens. If we go back to git status, this is where we're going to find out the information pertaining to what we have used via git add or what we have added and getting ready to put it into the repository itself. And it'll explicitly tell you, not the folder, but it's going to tell you all of the files inside of that folder that you have added to be committed. Now, if I run git commit, again, do -m and say add some initial thoughts on spaceships. Okay, so we've added a new commit. It's generated yet another hash in our log history. And now all of these files are being simultaneously added. So when you reference, again, when you reference a folder itself or a directory, all of those files will be explicitly individually added. And it's almost like you're writing git add for all the individual files over and over and over again by just calling the directory. So now we have a few exercises that I'd like you to go through. So there's a few exercises at the very bottom of the page. Let me copy the link. So we're going to start right here. So I want you all to work through this. I'm going to stop sharing my screen for a second. And I want you all to work through that. The first exercise is choosing a commit message. And so this kind of gets into what I was talking about earlier of what do we want to do to make something informative for our future selves and people we might be collaborating with. And then the next exercise is testing sort of which command you would use to save the contents of my file.txt. So it's a multiple choice. You can work through that, get the solution, committing multiple files. So I'll let you all work for, say, the next 15 minutes on these. And then we'll go on to the next episode of the lesson after I take any questions that people might have. So that would be, let's say 40 past the hour, wherever you are. So we'll come back together at 40 past the hour and discuss the answers to these exercises. You can put up the yes or a thumbs up when you're done with the exercises, and then I'll know if we can move on a little bit earlier. So. Okay, so we're coming up on 40 past the hour. I see a lot of yes signs up. So awesome. Thanks for working through this on your own. I'm just going to go over the answers to this and then we'll take a quick bio break. I know 3 hours is a long time to be on Zoom for everybody. So we're trying to be a little cognizant of that. And so this gets back to something that I mentioned. This first question gets back to something that I mentioned at the very beginning of my sort of portion of the workshop, choosing a commit message. So it says, which of the following commit messages would be most appropriate for the last commit made to Mars.txt? Option 1, which is just the word changes. Option 2, added line, but mummy will appreciate the lack of humidity to Mars.txt. Or 3, discuss effects of Mars's climate on the mummy. Answer 1 is not descriptive enough. So it's not clear what it is. I've encountered this collaborating with other people. One person I was collaborating on some software with wrote entropy as a commit message. And I don't know if there was a better word to describe the utter chaos of not writing descriptive commit messages. Answer 2 is redundant. So if we run git diff, like we would get that information. So it's like it's a bit long-winded, right? You don't need to be super explicit with added line and then the contents of the line to mars.txt. Sometimes I will write commit message that says added line and then reference specific line numbers to a program. Sometimes it's worth, or added comments. That's added comments to a file. But the most informative one is answer 3, where we have a good, short, descriptive, and imperative statement. So this is, the commit is discussing the effects of Mars's climate on our companion, the mummy. So now if we move to the next question, committing changes to Git, which of the following commands would save the changes of my file.txt to my local Git repository? The first option is git commit-m, and then the quotation statement is my recent changes. Git init my file.txt, and then run git commit, same commit message. Git add my file.txt, and then git commit-m my recent changes. And git commit-m my file.txt, my recent changes. So the answer is number 3. So number 1 would only work if the file had already been staged. Number 2 would try to create a new repository, and that wouldn't go over well, given what Michael has said about nesting Git repositories inside of each other. And so I said number 3 is correct. And number 4 would try and commit file my recent changes with the message my file.txt. So syntactically, the message comes first and then the file comes afterwards if you're trying to reference a specific file in the commit message. So this Git would get really confused with the last one. The next exercise was committing multiple files. So the staging area can hold changes from any number of files that you want to commit as a single snapshot. So you can keep adding stuff to that staging area before writing your commit message. So if you want to git add a file after you create it, go create another file, git add that new file, as this suggests. So add some text to mars.txt. Create a new file with your thoughts on Venus as a base for you and your friends. Don't go there, you'll melt. Add changes from both files to the staging area and commit those changes. So if we did that, we would open up the mars.txt in nano. We could see that we're going to add, maybe I should start a base on Venus to it. And then we're going to say, create this folder, or this file rather, Venus. Venus is a nice planet, and I definitely should consider it as a base. And now you can add both the files to the staging area in one line. So you can do that with this. You could also do that with the dot, like I showed you, which would add everything in the directory that's new. Or you can also do it with multiple commands. Say you've made the changes to Mars, you do git add mars.txt, you create the venus.txt file, and then you git add venus.txt. So now these are all ready to commit. You can check that but with running git status again. And if you're ready to commit, you can then use the git commit-m. Write plans to start a base on Venus. Again, we're writing a descriptive, informative, and imperative statement for our commit message. And this is outputting a new hash. Yours won't be exactly the same. I didn't mention that at the beginning, but your computer is going to create its own hashes, which we'll talk about in the next episode after this upcoming break. The final task for these problems to work through on your own was to create a new repository. And I'll walk everybody through this last one following along, because I think this is kind of a good thing to see again live. So I'm in the planets folder, and what we want to do is move up one directory. So we can do that with the cd and then the ... to move up one level in the folder hierarchy, which puts me back on desktop. So I'm going to make a directory called bio. I'm going to change into the directory called bio. And in here, I'm going to initialize Git with Git init. And I initialize an empty Git repository in, and then it gives me the full path. And then it'll tell you that it created a .git hidden folder. So now I want to make a file called me.txt with nano to write a short biography from Milwaukee, Wisconsin, moved to Tucson, worked at UA. Three years ago. Write that out, save that as me.txt. So I accidentally made a typo and then changed it and asked me if I wanted to save the buffer because I made a change and then changed it back. And nano is a little fussy like that sometimes. So I can add that to this repository by doing git add me.txt. So I added that file to this Git repository, and I'm going to say git commit -m add biography file. Okay, and then if I do git diff me.txt, it won't show me anything. So like if I were to go back in and add a line to me.txt and say nano me.txt and a line. Say Ryan also really likes bicycles, which is a true statement. I added that line. Now I can say git diff me.txt. So have this original, it's telling me that I added this line. And I can then go back and say git add. I'll use the shortcut to add everything in the folder. I'll do git commit -m. Added hobbies to bio. Okay. And that brings us to the end of committing, making changes, tracking those changes. And I think right now what we're going to do is we're going to take a 10-minute bio break. We'll be back at 11, top of the hour, 11 a.m. Pacific time, or whatever time it is, wherever you are, it'll be at the top of the hour. And then I'll go through some of how do we explore our Git history in these repositories that we've created. We'll go back to our mummy repository. Sharing. And I will also be right back at 11. If you have any questions, someone will be in the chat eventually answering them. All right, so we're back at the top of the hour. Hopefully y'all are just getting back to your computers. All right, so let me just put the next lesson episode in the chat. So now we are going to go through, so we were talking about, I mentioned hashes before and talking about the commit history. Now we're going to do a little bit of a deep dive into how do you move around in the history? How do you recover a specific version of a file from the past? And we're going to talk about what the head of a repository is and how to use it, and finding the Git commit numbers or hashes. And we're going to compare different versions of the tracked files, and we're going to restore older versions of the files. So first off, I'm back in the planets folder. So, so if I go back to my home directory on my computer, so I can get there by going into the desktop. And planets. And I want to open mars.txt again. We're going to be playing around with this file yet again. And we're going to add another line to this page down and say add an ill-considered change. Write that out to the file. Thank you, Mary. I've been so good about it, and then I missed it. let me rewind. All right, so we will exit. So what I did was I went back into the desktop and the planets directory. I used nano to open mars.txt, and I added this line right here, an ill-considered change. Okay, I'll just give everybody a second to get caught up due to my lack of screen sharing. Just exit nano. And so if I run cat mars.txt, we can see that the new text is here. So we have our first version of the file, second, third, all these different lines that we've added over the course of today. And then we have the line that we just added, an ill-considered change. So now we're going to try doing something with git diff. We're going to invoke head. So we're going to say git diff, and this is all capitals, head mars.txt. Okay. So this is going to output our different hashes. We're going to see the line that we added. And this is the same as what you would get even if you left out head, right? So what we can do is what we can do with this head argument for git diff is we can add a tilde and a number. And so like when I run git diff without head, I get this. It's right here. So let me clear the screen so that it's a little more apparent. Okay, and then if I do the git diff head, get the exact same output. If I clear the screen again, actually I'll leave it. So git diff, and then we'll do head, and then this is the tilde sign 1 mars.txt. Okay. We go through the different notations, changing the numbers. You can see this is going, so what the head is referencing is the top of your commit history, the head. And by putting tilde and 1, it's doing the most recent version. Now, if you notice when I changed it to 2, that's going another commit backwards in the history. And so it's saying that between our second commit, second oldest, or second newest rather, sorry, second newest commit, this is what has been added since then. We can go back even further and we can go to the number 3. And this will take us all the way back to, this is our first commit in this file versus all of the other changes that we've made. And if you look very critically and carefully, you'll see that the index number is changing. You can also use a command called Git Show. So you can say Git Show, and then say head tilde, and then let's choose the number 3. We'll choose 3. So that's going to show us what was committed in that file at that particular commit point. Also going to give us some information, the full commit hash up here in this sort of off yellow color. Who did it, when they did it, the commit message. And then it's going to run the diff between mars.txt and mars.txt. And this is going to say that it's a new file. So this was created, this is going all the way back in the commit history to the creation of this file. So if you notice the tilde notation, the 1 is meaning the previous commit. So if I put in like head tilde 123, that would be asking Git to go back 123 commits with either the whole repository or an individual file. And so we have this identifier that we were given for our first commit right here. So let's just copy this up here. And we can also reference the full hash in the git diff, mars.txt. Right? So that's telling us from that original hash how much has changed. We can also shorthand this. We can just use the first 7 characters of it. So if we go all the way back here, and I delete this all the way, count 1, 2, 3, 4, 5, 6, 7. Go this, right? That should be 7 characters. First 7 characters of hash, we'll get the same result, right? So there are times where the 40-character string is important. It's also kind of annoying to write it out, so you can get away with writing the first 7 characters of the hash string. And so we've made these changes to the file. We can do Git Status. So it's still showing that it's modified. We've just been exploring how our changes that have not been added are versus the history of the repository. If we wanted to revert our file back, so we've changed this, and we know when we run cat mars.txt that we have put in quite literally an ill-considered change. And so one command you can use is Git Checkout. So Git Checkout and then head mars.txt, right? And so when we run this, something interesting will happen. Okay, so it says updated 1 path, and then from that 7 alphanumeric beginning of the hash for the commit. And now if I cat mars.txt, what's happened is it went to the head of the repository and removed the changes that we made and reverted the file back to what we had saved in version control. And this is, I think, the power of Git. This right here of being, sitting down and saying, oh, crud, I forgot to make these other changes, or I wrote This has happened to me a couple of times where I've been modifying a program on like a remote computer. And then I'm like, no, that's not what needed to happen. Like, it's not fixing the problem. And so you can use this Git Checkout head for a specific file to bounce it back to the last commit, right? So this is only going to work if you have not added and committed your changes to the file. We can also do, so if I see that this right here, this, copy this hash, say git checkout mars.text. Just say updated 0 paths, right? Because we've already changed it. So if we wanted to go all the way back, look at oops. If we go git show head, and then we'll go, let's try going all the way back. TXT. All right, so this is going to give us cold and dry, but everything is my favorite color. Gives us this full hash up here. I'm just going to take the first 7 characters of that again. Say 1, 2, 3, 4, 5, 6, 7. And so if I wanted to do this, what I can do with Git Checkout now is I can revert this all the way back to that initial commit, mars.text, from that first 7 digits of the hash. Okay, and now if I cat mars.text, it's all the way back to the beginning, or first commit. And if we look at Git Status, it's going to tell us that we've modified mars.text. So it's already in the staging area. And if we don't want to go this far back in our commit history, I'm going to say, oh, this was a mistake. I only wanted to change a few things. I only wanted to get rid of that last line. I didn't want to go all the way back to the beginning. And this is particularly relevant when you have very, very large files, particularly programs and code bases that you might be collaboratively working on with others. So if I want to get back to where I was with the very last commit, I can run git checkout head. It's going to give me that updated 1 path from that particular hash. And I can run cat mars.text. And it's taken us all the way back to cold and dry, but everything is my favorite color. The 2 moons may not be a problem for Wolfman, but the mummy will appreciate the lack of humidity. There's also some information in here about detached head states. I think we're going to skip that for today. It's a little complex. And I'm going to pass this off to Michael so we can spend a little bit of time working with some of the remote Git hosting for the last like 45 minutes that we're all together. So if you're looking for a place to pick up in the Carpentries tutorial, you want to work through this all on your own, this would be starting with the history lesson would be a good place. And I will stop sharing my screen. Just give you a little bit of a cursory introduction to how do you move around in your Git history, and with some of the stuff that Michael will show you with the hosted Git, like using stuff like GitHub, you can actually do this a little bit easier. So,
all right, thank you, Ryan. Yeah, so as Ryan said, there's just due to time constraints, portions of this lesson that we're not going to get to. So I would recommend checking out the rest of the Exploring History episode of this lesson. The next one is called Ignoring Things. And again, for the sake of time, we're going to skip that one, but that's very useful. Essentially, you can tell Git that there are certain files you don't want to track, that you don't want it to keep track of. And that can be really beneficial for many reasons. Git doesn't like dealing with really huge files. It can really slow things down. There might just be sensitive information that you don't want to put on the, keep in the Git log. So there are various reasons you might want to do that. So that's worth reading that lesson as well. But we're going to skip over to the remotes in GitHub lesson, because this is sort of, we want to get you up and running with putting your Git repositories, hosting them on GitHub, which will allow other people to collaborate with you, will allow you to sort of keep your work in one area. If you're working between multiple computers, this can make things really nice. There are many, many reasons to utilize this very powerful feature of working with Git. So version control, we've seen a lot of benefits that it can have, but collaborating with others is something we've talked about a lot, but we haven't really touched on yet. So basically, the easiest way to collaborate is to have a repository hosted in some central location, and then everyone else who's interacting with it can sort of pull and push changes to this central hub. So everyone is accessing sort of this global main copy of the repository, and everyone can interact and work with that. So there are a bunch of different services that allow you to host, like GitHub, Bitbucket, or GitLab. But we're going to stick to GitHub. So part of this setup instructions was to create a GitHub account. If you haven't done so yet, you can try to get that done now. Otherwise, we'll note that this meeting is being, or this workshop is being recorded. So if you're behind at this point, you can go ahead and check that out later. We'll post that. That'll go up on the AG2PI site, and we'll put it into this HackMD as well. So if you'd rather just follow along here because you haven't gotten a GitHub account set up yet, that's a-okay. So I am going to share screen of this web page. So we're going to log into GitHub, and we're going to, from GitHub, we're going to create a new repository, which we will name planets. So I'm going to log into github.com, which will take me here. Now I would like to create a new repository. Click that. And now we see this page with some different stuff. So one thing is the owner of the repository. That's me. That's my GitHub username. We are going to connect this to a local repository that we already have going on our computers, right? We already have the planets repository locally. So we're going to make sure it's empty. So we don't want to check any of these boxes to add a README file or a git ignore or license. We're going to leave these unchecked.
Could you zoom in on your screen, Michael? It's a bit difficult to read.
Sorry, what was that?
Could you make the screen a little bit bigger? It's a bit difficult to read.
Is that better?
If it's still like kind of, I think you've selected like Google Chrome, so it's making it very narrow on my screen.
Oh, weird. Okay, so that's not.
Yeah, so I think it has to do with the screen share itself rather than. So I think you selected like the Google Chrome browser instead of like the screen that it's on.
Oh, okay. Let's then see if that works. Give me 1 sec just to make sure I don't have things on screen. All right, so I'm just gonna, let's try that then. I will just try sharing this whole desktop screen. How does this look?
It looks good. If you just make it like the full screen and then zoom in, I think it'll be easier to read. Yep, that's already a lot better.
All right, wonderful. Okay, so I'm then just going to move this here for the time being, just so I can keep that up. Okay, wonderful. So the next thing we'll do is we will create a repository here that has the same name as our repository. So we're gonna name it planets. It'll let me know that's available. I don't already have a repository named planets. And then I'm gonna go ahead and click create repository. So initialize, and then all of a sudden you'll get some instructions for how to do stuff. So it's got some information on how to configure the local repository, and it's basically doing the process that we had before of on GitHub. Essentially, it's doing like make dir planets, cd into planets, and then do git init. So now we've got these two repositories that are similar, but they don't quite match each other yet, right? Because ours has changes in it, but this repository doesn't have anything in it yet. So on GitHub, it's basically just an empty planets directory and then a .git folder inside of that. So like the work on that mars.txt file that we made isn't here because we haven't connected the two at all. So the next thing we're gonna do is make the GitHub repository into a remote for our local repository. So remote refers to a remote, not on your computer linkage. Like a remote is, I guess, just a noun that we use. It's a remote for our repository. So we have this string of text here that tells us how we can essentially set them up. So there are two different ways to link these two together to tell Git on our computer that this is the remote of that repository. So there are two methods, HTTPS and SSH. We're going to be using SSH today, and we'll walk you through that whole process. So you want to go ahead and click this SSH button. So it shows something like this, but with your GitHub name here. And then we'll click this button to copy. So we'll copy that text. We'll come over here. We will then type in the following command. We will type in, and just make sure I'm in the right spot. Oh, see, no, I'm in moons. So now we want to make sure I've got everything correct here. Wonderful. Git log. Wonderful. All right, so we're all good here. Sorry, one sec. I goofed something up actually while I was keeping up with everything. I am just going to move there. So now, all right, so now I've got everything set. I've got my .git repository. I've got mars.txt. All right, we're good to go here. So now to tell this Git repository that it is going to use this GitHub repository as a remote, I will type git remote add origin, and then I will paste with Command V or Control V the copied line here. So what this is going to say is it's going to tell Git to add this as a remote, and it's going to be the origin. So this is like the origin of our repository is going to be here. So origin will be the local name that's used to refer to the remote repository. So basically it's going to say Git on our computer, Git here, has this thing called origin. which refers to this. And that's how it's going to keep track of how these two interact. So we will run this command. And then to check and make sure that went correctly, we're going to run git remote -v. Make sure that it went correctly. So now we get told, all right, we have this thing called origin, and we'll talk about what fetching and pushing mean in a bit. But if you see something like this, but with your name here instead of my GitHub name, everything's going correctly. So now we're going to come to dealing with SSH. So SSH, there are different protocols, there are different ways of having two computers talk to each other, essentially. Right, for the sake of security, you can imagine that you want to make sure that two computers interacting with each other are doing so because they're supposed to, and not because someone is, trying to access your computer who shouldn't be. So we need to set up a way for our computer to authenticate with GitHub, so it knows that it's us trying to connect to the remote repository. So we're going to use a method that's commonly used in many, many different contexts to authenticate access from the command line. If you end up ever using like a high performance computing cluster or something, you will very frequently have to SSH into it. So it's called SSH, which stands for Secure Shell Protocol. And it's a cryptographic protocol that allows secure communication between computers, even if the network used to connect them, like the internet, is otherwise insecure. So SSH uses what we call a key pair. So this is two keys, which are just like long strings of text that fit together, essentially. They work together to validate our access between the computers. So one key is publicly known. That's the one that gets shared with GitHub. So GitHub knows the public key. And there is another key called a private key that you keep private. This is not something you will ever memorize. This is not something you should store anywhere other than just on your computer. It should be kept very safe. Do never, ever share your private key, okay? So the public key is like a padlock, and the private key is something that fits into it and opens it. So you would put the padlock on something public, like your GitHub account. But then you keep that key so that only you can access it. So we're now going to do a very minimum process of setting up an SSH key, and then we'll add that public key to a GitHub account. So first thing we'll do is to check what key pairs already exist on our computer. So your computer may already have some SSH key pairs set up. So to check them, we'll run ls-al for all output, all files, and then long for the long output. And then we'll do tilde, which is our home directory, // We'll run that. So I've got a couple different, this is what a key pair looks like. There's the public, ends with .pub, and the this one is the private key. So your output might look different. So your output might look like cannot access users /yourname/.ssh, no such file or directory. What'll happen then is that just means that you've never set up SSH keys before, so it hasn't made that directory. So what we can do then is we can run a command to generate an SSH key. So, so the way we'll do that is this command called ssh-keygen. Then we'll pass it -t, and then ed25519, which is the type of like cryptographic sequence that we want to use, and then a space -C, and then in quotes your email. All right. So if you run this, you should get an output that says generating public/private ed25519 key pair. And then it'll say enter file in which to save the key. So I'll run this. Let me try this. From our all right, I want to store it in the default location. So I'm just going to put it in here. Now, for passphrases, it's going to prompt you to enter a passphrase. Since if you're using, say, a lab laptop that other people might have access to, or you just, for extra security, you want to create a passphrase here. So you want this to be something memorable, because there's no reset password option. Like, this password will be set once and you will never be able to see it or change it in any way. Okay. So one thing to note is that when you're typing a password in the command line, nothing shows up. So be careful when you're typing, because you can't see if you made a typo, you can't even see how long it is. Then you'll hit enter. Then it'll prompt you for that same passphrase again. And then I will type the same thing again, and then hit enter. So now it will let me know that the identification has been saved here, and then the public key has been saved here. So you can see the names of the two match, but the public one stands with ends with .pub. So the identification, this one, is the private key, which you should never share it, and really you never need to look at it. So just don't mess with it. The key fingerprint is essentially a shorter version of the public key. So now that we have this created, if we run that same command we did before, ls-al tilde /.ssh and run that, we'll now see that these two new ones popped up. We'll see they were created just now. So next thing we'll do is we'll run and we can check and see if GitHub can read our authentication. So let's try this. Let's run ssh-t. We'll try git at github.com and run that. So mine worked because I've already actually done this, but you will probably get a message that says the authenticity of host github.com can't be established. This key is not known by any other names, et cetera, et cetera. So basically, what we haven't done yet is we haven't given GitHub our public key. So we want to give GitHub this public key. We need GitHub to know what our public key is so it can communicate back and forth. So what we'll do now is we will run a command to print out our public key. So I'll run cat tilde /.ssh/id. I'll hit tab to see what my options are. And let's do the ed25519.pub. Do not do the one without .pub. Just do the one with .pub. So what we should have come out is something that looks like this. So once you've got this here, the next thing you're going to do is you're going to go on GitHub. You're going to click on your profile icon up here in the top right. And then you're going to go down to settings. So now here I see a bunch of stuff. Then we'll go find the SSH and GPG keys here. We will click on that. And now we're going to click the new SSH key button. So now we get a title. So as you can see before, I gave titles like lab computer and then my MacBook. So one thing that's nice about keys like this is you can generate and delete them sort of as frequently as you want. You can think of them as just, it's essentially like a cheap or a free padlock and key set. And if you think one got messed up, if you think maybe something happened to it, if you lost it, you can just delete it and generate a new one and add it here in the same way. So you can add an SSH key and you'll give it a name. So give it an informative one. If you're on your work laptop right now, maybe call it work laptop. If you're on your personal laptop, call it that. But give it a name. And then the, let's see, so then after you've added the title, you want to actually paste the SSH key in here. So you'll paste that whole output that we got here. You'll paste that into this spot. I'm not going to add this extra key because I don't need it. And generally, you don't want to add keys when they don't need to be there. But you click or add SSH key, and then what should happen is if you go back to this point, you should see you should see that key showed up. It'll have some little information on it, and then it should have that title. So you can go ahead and do that with the key that we just created. And now what we've got is your computer has that private key. GitHub has the public key, or basically the padlock. And now you can have the two communicate. And now your computer knows, well, GitHub has the padlock for this private key. Let's go unlock that. So, excuse me. The next thing we'll do is once you have that done, we can go back and we can type out SSH-T git at github.com. Now you should see the same thing that you saw before when I ran it, which is, hi, your GitHub name, you've successfully authenticated, but GitHub does not provide shell access. That's what we want to see. So we want to make sure that everyone can get this part done. So I'm going to take 5 minutes. We're going to take 5 minutes here. And anyone who hasn't gotten this to work, if you have gotten this to work, please do the green yes checkmark react. And if you haven't gotten it to work, you can put up the red, or you can in the chat, excuse me, you can feel free to ask a question in the chat and we will help you get up to this point. Take 5 minutes, just make sure everyone can get to this point who wants to be there. All right, folks, I think that's been enough time to make sure everyone's got things working. Here, I'll go back. All right, here we go. So now that we've got our SSH keys set up and we've got it such that our computers now know how to, our computer knows how to talk to GitHub, we're going to actually move our changes that we made locally to the remote repository. So this is called pushing. So now that the authentication is set up, we can actually make that happen. So the way we'll do this is we will type git push origin main. So we'll run that, and you will probably be prompted for a passphrase. If you did some other advanced stuff that actually gets talked about in the lesson, but I didn't get into it, you might not be prompted for a passphrase. But if you put in a passphrase when you set up that SSH key, that'll happen. So now we're in this state where our local and remote repositories now they know, they have the same, let me see, let me go back. So now they've got the same stuff. All right. So now I can go in and I can see, I remember I accidentally put mine into the moons directory. Well, I forgot to commit those changes before I pushed this up. But what we can see is now on the GitHub repository, instead of that instructions page, we actually get stuff showing up here. So yours should just be a mars.txt, but you can see it here. We have the commit. We see that that last commit I made was 35 minutes ago. So we're able to now make these changes go back and forth to our repository on GitHub. So the next thing we'll do is we'll show you how to pull changes down as well. So we can pull changes down from GitHub by running git pull origin main. Now here we'll get a message that says it's telling us we're going from main, we're going to fetch head, and it's already up to date. So that's saying basically the two match. My local repository and this remote repository match up with each other. So there's no other changes that need to be done. So one thing that's pretty nice is you can actually make changes to files. It's often quite slick to be able to do this just to small files directly on GitHub. So we'll just show you sort of briefly what that might look like, and then we will call it a day. There's more in this lesson, and I recommend that on your own time you go through and finish off the content of this Git lesson. But I'm just going to show you one quick thing. So we're going to make a little change to the mars.txt. So on your computer, well, I'll show you actually. So we can see if I run git status, remember I deleted the moon directory. So there's no moon/mars.txt, but now I have this thing that's just mars.txt. So I'm going to git add dot, I'm going to git commit -m, and I'm going to give it the message moved mars file out of moons. All right, and then I'll run git push again. Whoop. So this is something you might get if so. Before we said I ran git push origin main. Well, I don't necessarily want to have to run that all the time. So basically, I can set it so that the remote sort of permanently knows that what's upstream of it should be the main branch. So this is just gonna set it so that GitHub knows that these two branches, our main branches, should match up. So I'm gonna run that. I'm gonna run git push -- set upstream origin main. So now it knows that those two should be linked as well. If I refresh my planets now, we can see that I no longer have that moons directory, and I just have my mars.txt file. So now from here, we can go and we can actually click this little pencil icon to edit this file. So I'm just going to put in a fourth line that says changing a line directly on GitHub is pretty neat. So I can go here. Again, you can give a commit message here. So I'm going to just do my commit message, which is editing Mars file on GitHub. All right, and then I can commit those changes. So now this commit exists here. So now our GitHub directory is, our GitHub repository is in a different state than our local repository. Just as before, the GitHub or our local repository had changes that the GitHub repository didn't, such as the existence of that Mars file. Now it's the reverse. It has changes that we don't locally. So now, prior we pushed our changes to GitHub. Now GitHub has changes that we don't. So we can run git pull. We can do git pull origin main. And now we'll see that some changes occurred. So we see that we updated to a new hash, and we see one file changed, one insertion. So it's saying we added one line to that mars.txt. And now if I cat mars.txt and run that, I will have that new fourth line showing up here. So this is generally an important thing to remember to do is if you're working on collaborative projects, if you're the only one working on a project and you're only doing it on one computer, then sort of any changes you make locally and put up to GitHub, as long as you didn't change anything on GitHub, you'll be fine bringing it back down. But if maybe you're editing files on GitHub, like I just did, or if someone else is collaborating with you and they're putting changes onto GitHub, then you want to make sure every time you're working that you're working with the most up-to-date version. So it's often worth running git pull just to start, just to make sure. And once you see this already up to date, then we know we're good. We know there's nothing, we're not going to run into any issues with we're making changes, but there were other changes that we didn't have while we were making ours. This makes sure everything is in sync. So with that, this is a good stopping point for this lesson. So as we said before, there are a lot of different things you can do with Git that we didn't quite have time to get into in this relatively short workshop. So this Git lesson, on the software carpentry lesson, goes further into getting into collaborations and conflicts that might occur between changes being made to the same file, how to deal with conflicts between those changes. But in general, we've sort of gotten you this foundational working with Git and GitHub, how the two relate to each other. We also put into the HackMD a page that I think is very, very useful, this website called Learn Git Branching. So actually, I can show you that briefly. Learn Git branching. So this is a really fantastic site that has these different lessons, and it has okay, I'm just going to skip through these, but it's got really nice graphical representations of like what a Git sort of repository looks like, where different things point to, and you actually get to type in Git commands, and it will change this graph based on the commands that you entered and show you how these things relate. So I think this is an incredibly powerful hands-on way to put some of this stuff into action. It's not an actual repository though, so you don't need to worry about messing anything up. It's a nice series of lessons. Honestly, I myself go through this whole thing maybe once every 6 months or so. I go through all the different levels. It gets into some fairly advanced stuff. And I think it's really, really worthwhile if you're going to be using Git in a broad way. So with that, I think we're going to end the workshop for today. I guess we have 5 minutes, so if anyone has any other questions, we're happy to take those now. We will be uploading the recording from today onto YouTube, and then we will post that link. It'll be both on the AG2PI site, and we'll put it onto the we'll put that into HackMD as well. So yeah, with that, thank you all for joining us. If you have any questions, feel free to stick around for the next 5 minutes or so. Happy to answer any questions you might have. Otherwise, thank you for coming, and have a great rest of your day.